Welcome back to the shed. Here we've got a Land Rover Defender muffler, which is due to be swapped out for a little bit of exhaust work on the car. So yeah, this particular unit's all mild steel. We've gone through the steps of marking up the lines, roughly, the inlets and outlets. They are offset by about 85mm. So what we've got is the opportunity to make some exhaust piping with a fairly steady bend to allow this whole unit to be replaced. So we've got a 3-bolt exhaust flange on that side. On this far side we've just got the old 2-bolt style. Yeah, we'll be replacing it with these sections of aluminized mild steel exhaust piping, which has been marked out and cut on the bandsaw. So this is a 45-degree bend. You can buy these off the shelf. This is a 2.5-inch diameter pipe. So yeah, with this we should be able to get the whole unit squared away with a series of bends which will match the required angle. So yeah, we'll do some welding on this, run through a few little features and things that we're doing with the welding process and the prep potentially, and yeah, see how it works in a real world application. So let's get into it. So the concern with getting this exhaust pipe made is that we've got this muffler here with a offset pipe inlet and outlet, and what we've got here is two lines which are between sort of roughly 85mm apart. We're just using 80mm as our offset, just as a round number. But the problem we're faced with is we've got our two 45-degree bends, which we can see here, and we need to pretty much chop a section out of the middle, like you can see we've done, to make sure that the outlet on this side and this line, where they join, creates that 80mm offset. So to do that took a little bit of thinking. Thought I might go through the rationale of what a bit of basic, really amateur level pipe fitting might look like. So we'll pause it here, I'll get some drawing happening and we'll see if we can explain it. So yeah, thinking about our conundrum, we've got two pipes, an inlet and an outlet, and we can assume they're sort of parallel lines. And then from there we know that this distance from here to here is 80mm, and we'll assume that's a right angle. And then essentially what we've got is a right angle triangle with a 45-degree bend here, which is our first pipe, and sorry, 45-degree here, of course, and then 45 degrees here. So from there it becomes like a trigonometry thing, trigonometry calculation, which people may remember from school, but long time ago. So the rule of thumb to use is the constant for, I believe it's one of the trigonometric functions, which is 1.414. So from there we'd get the 80mm offset, this amount here, and the constant for 45, which is times 1.414, and that gives us this number, which is essentially the distance between the center line of this pipe, which is a 45-degree bend. So if you can imagine the exhaust pipe goes like this, and this line is actually the center line of the pipe. So when we get to it, we can get our pipe. We can, I don't even know whether you'll see this. There it is. So that line there is roughly the center line of this pipe. For all intents and purposes on this job, we just eyeballed it. And then from this point here, which is the crossover between the center for this length and then the center for the length we've cut off, from that point there, 113 millimeters is where we made our cut. So that gives us the cut lines that we have to make, which now gives us roughly, within like, you know, exhaust pipe tolerances, which aren't massive, our offset that we need of 80 millimeters. So yeah, that's the easy way around it. Like the alternative is to cut, fit, measure, cut, fit, measure, and fair bit of work, but remembering the constant of 1.414 and multiply that by your offset height, you can quite easily get the number that you need, and that will put you pretty much in the ballpark. So yeah, next step, we'll clean the pipe up and get it ready for some tacking. Yeah, so to prep the pipe, we've cut it on the bandsaw. We've got a bit of a burr on the inside, as you might be able to see. See it quite pronounced over there. So we've got this handy dandy deburring tool, which we can just run around the inside. And that cleans it right up. We've still got the outside to worry about. We've still got the remnants of our tape on here that was there from our markup phase when we were trying to measure our circumference around the pipe. In a perfect world, we'd have something like a pipe wrap or something that's a bit less flexible in its long dimension to allow us to go around the pipe, but for this one it was just a piece of tape and we just sort of eyeballed it. The bandsaw that I used cuts somewhat straight, but from there there's, you know, a bit of a work with in this case a half round file, which will clean it up and give us pretty good finish enough to get a weld on. So yeah, we'll do this off camera and yeah, come back when it's ready to weld. So yeah, started out, silly me, had the hand tools out, then realised I've got a linishing belt on a multi-tool on a bench grinder. So yeah, gave that a bit of a razz up, a bit too noisy and wild to have on camera with any sort of worthwhile content. Cleaned it right up. We've got some nice straight edges, somewhat straight edges, which now gives us perfect, almost perfect bend to allow our 80mm offset. So there we are. So that's what we've got. As it stands, the distance between here and there is about 80mm. So that will meet our offset requirement for our replacement of our muffler. So that will fit right in there like so. Hard to see with a hand in the way, but you get the idea. And that's ready to start fitting up. So yeah, here we go. So before we start welding, I'll just go through the setup that I'm using. So this is the EWM torch for the Tetrix 230 that I've got. So this is a 26 series TIG torch. And what I've got with it is the stubby kit. This is a stubby kit from Binzel, who make a lot of welding torch related gear. Thought I'd run through the setup. It's pretty basic. We've got a gas lens, which has got a gauze. This is for a 2.4 tungsten. So this just screws into the front of the torch like so. So it's just finger tight, and then I usually, don't hate on me, just give it like, just so that it makes electrical contact, just give it a little bit of a turn, not enough to bugger the threads up or anything. We've got a short collet body, sorry, short collet, which is a split type. You might be able to see the split. So that just grips the tungsten by compression. So these are specific to the size of tungstens you use. This here, we've got a nicely sharpened grey tipped seriated tungsten, I think it is, which is nice and short, so that will go into the torch assembly like so. Probably do it from the other end. This is a stubby back cap. No need to run a stubby, but because I've got a short tungsten in there, there's no need to have it stupid long. This will fit in there like so, and this alumina cup, it's a number 7, so that's 7/16 of a number 7, 7/16 of an inch. Try and keep you in frame. That goes on the front of the torch like so, just finger tight, and maintain the tungsten stick out. You can get real technical and measure this, but generally you don't want it any longer than the bore of the cup, internal bore. So I usually just do just long enough. I just eyeball it, I don't get super critical with it. Tighten it up, that compresses everything within the torch, and now that tungsten is not going anywhere. We've got good electrical conductivity through the torch and the torch neck, and yeah, we're ready to rock and roll. So we'll go to the machine, show what the settings are like. We might use Spotmatic on this one. See how we travel. So I've just finished doing some test tacks on the offcut from our exhaust tubing. So I've set the machine up to 60 amps with a 2.5 second spot time. And the prep we've done on this aluminized pipe is just a quick brush with a stainless steel wire brush. So you can see with the tacks we've got, you know, the fit up's not too bad. It's better than what you'd get with an angle grinder. But we've got nice flat tacks. Got very little issues with those. Even there where the gap has opened up a bit. We were using a 1.6mm steel TIG filler rod, which is enough for what we need. And yeah, see that one, that was at a shorter time. That was, I think, 1 second spot time. And yeah, that one a bit cold as well. And that was the starting amperage, which was 100 amps and way too hot. So yeah, that was at a 0.5 second 100 amps. So yeah, not enough, and obviously no filler there either, other than the big one right in the middle. So yeah, not how to do it, getting better, acceptable. So yeah, now it's time to burn some actual material and get it done. Righto, so just running through the settings on the machine. If you've watched this channel before, you'll know this is the Tetrix 230 from EWM. This machine is currently set up in DC mode. Obviously in its TIG welding function. Here you can see the red light is illuminated. That means Spotmatic. So that's an automatic spot welding function. So what essentially happens is when you have your TIG torch and your tungsten, once you touch the job, the arc will initiate and it will run through a spot for a defined period of time. In this case, 3 seconds. Time for the spot. We're welding at 60 amps. And yeah, that's pretty much the long and the short of it. I'll probably add a bit of filler just to get the tack started and then wet it down. when I hit the trigger button on the machine, on the torch I should say, the red light there will illuminate, which will mean it will start flashing, which will mean that it's ready to spot weld once the tungsten contacts the job, and then you lift off and then it initiates. So with a high frequency start. So that's pretty much the settings. Not too much more to go into it there. Like, yeah, not much to really talk about. Main idea, 60 amps, 3 seconds with some filler. Rightio, so this is the fit up for our exhaust pipe. So I've just scribed 2 lines on the workbench, being 85mm apart, and our joint's been prepared with a wire brush. Got a magnet there just to hold everything in line. You can see it's pretty much bang on where it needs to be. So that will mimic the offset of these pipes, these flanges. So we'll see if we can get this camera tripod set up. And yes, here we go. So TIG torch is all set up. We've got our earth clamp up the back on the bench. We've got our filler. Try and do this all around the camera. Get some weight off that cable. And here we go. So I've just hit the trigger button to commence the spot timer, or spotmatic. Contact the job, lift off. So that one's not too bad. We'll give it another shot this time around here. We just gave that one a second hit so that it melts in. As it stands, that's tacked. Not great, but it's holding. Got a bit of a gap issue on the other side, which we might try and bend this into place. Give it a bit of percussive maintenance. Alright, stay tuned. We'll net for the next instalment. So to close the gap up, we've gone a fair bit of the way to making that somewhat acceptable. Just bolted it into the pipe vise there, and then just used some steel shims just to sort of tweak everything in the direction it needs to go. So from there, I think that's, the fit up isn't 100% on, there's maybe half a mil or something in it, but with a bit of pressure in the right direction and a bit of attack with the welder, I think we'll be where we need to be. So see if we can get you set up there. The benefit of that spotmatic function is that you don't have to worry about touching a button. You don't have to touch a button to weld. You can just get it started where you want, and then you can, choke right up on it if you need to, or use another hand to manipulate the job, and you'll be set. So just give it a bit of a nudge in the right direction, helmet down, touch off, and that's fused, so that's good. Follow it up with a tack over here, touch off, grab a filler, wet it around, and we're done. So that's as easy as it is. So now it's just a matter of getting it welded out, which I won't subject you to on camera. Right, time to weld it out. We've decided to switch things up a bit. We've got the machine set on its kilohertz pulsing range. So we're going to give this a whirl because we can. At 7,000 hertz pulse frequency. So this will be, don't know whether the camera will pick it up. It'll be a really high pitched noise. We should just be able to trace the line and fill it in without too much filler metal, but give it a go. There's no welding lens on this camera, so it might get a bit bright, but if you're afraid of an arc flash, cover your eyes. Needed a bit more filler than we thought, so we'll drop the amps a bit, I think. And yeah, that was an area of some pretty crappy fit ups, so we've got a bit of a gap to deal with. So what we might do is loosen it off a bit, see if we can get some action on the other side. And give that a whirl. That went a bit better, so went to plan. Didn't blow any holes through this time, so go me. If it will focus. So you can see the fit up gets worse and worse as we go around. We actually cracked our tack that we'd begun with and started to sort of keyhole there, so, and at the start, so that's a pain. But anyway, we'll persevere and yeah, see if we can get a picture of the finished product once it's done. So the next point in the exhaust build is to work out how long our bend needs to be overall from flange to flange, so to replace that whole muffler section. So I laid it on the bench, marked it out, drew a vertical line off each flange surface, gave ourselves a mark on the bench there, which conveniently turns out to be 750mm. So that's an easy number to work off. Yeah, so now we just need to extend our exhaust pipe from the bend end to 750mm on one side or both. I'm not sure how I'll do that yet, but that's the game plan. Now, this being the internet, those of you that have been around for a while probably know this is a cruel and nasty place. So as such, disclaimer, this is not a weld porn channel. You're not going to get any Instagram worthy beads around here, so I'm only going to show you the good bit. So there you go. I actually switched it up to a standard pulse setting with half a second peak current at 60 amps with a background current of around 30 for 1.5 seconds. So yeah, burst of heat with a background current allowed a good amount of time to gradually feed filler. When we look inside this, can't even see it, but inside the penetration is good. We don't have any significant problems in there which are going to give us any grief, and overall I think that's for its intended use, which is an exhaust system and a four-wheel drive, a dirty old Land Rover, this will be more than adequate. So yeah, I'll probably let the skills develop a bit before I start welding up parts for Ferrari or NASCAR or the V8 supercars, but until then this will have to do. And yeah, now the next section is to get set up on the overall length of the exhaust section. So, righto, so this is the bent assembly there that's been welded up. Just got this new section, 325mm long, from there to there, marked, cut out, deburred, and we've been doing some fit up on this one. So good lesson, unlike before when I completely wrecked, blew a few holes through the initial part there due to poor fit up. Here we're taking our time, learning from our mistakes and doing it properly. So we've got this in the pipe vise, we've just got a piece of angle clamped down. This is just allowing a straight channel for everything to sit into. We're dealing with round material here, pipe, tube, which yeah, we've put a reference mark on it. You can see a black mark there. Got another reference line on the other side, which we're lining up to, and we've been going back and forwards to the linisher to take off any high spots and make sure that fit up is good. So at the moment this is a very smooth transition. There's no significant areas, high or low, or gaps to bridge. So this should allow the weld fit up to be quite satisfactory. So yeah, comes the point where we'll get to welding again. We might give that kilohertz pulsing another go. See if we can get some action there. So we'll pause the video for a sec. We'll get the machine set up, get geared up, and get ready to lay some more weld. Alright, back into it again. We've given the material a bit of a brush up with wire brush. Just over there, we stole Alan's brush. Hopefully it doesn't matter. He doesn't mind. So, alright, enough lame jokes, let's get into it. So, once again, just recap, we're on a kilohertz pulsing, 6 kilohertz. 60 amps. Yeah, we'll see how far we can get through without any filler, but we'll give it a red hot go. Contact. Anyone playing along at home, I've just changed the torch consumables, just whacked a longer tungsten in there and put a medium back cap on. Beauty of YouTube and video editing is that all my mistakes you don't get to see. So this could very well, in your eyes, be a flawless victory. In actual fact, far from it. Right, just rotating the assembly around. You can see the fit up's remaining quite good. Alright, whack another tack on there and see if we can do a bit of a longer pass. So seems to be welding quite well without any filler at all. Yeah, we'll give it a keep on cracking along with it. That's actually getting a bit hot. Anyway, we'll finish welding out and show you at the end. So that's the weld out done. Yeah, once again, the overall length of the pipe is good. We just need to whack a couple of flanges on the ends. The inside diameter of this flange is the same as a bit larger than the outside diameter of the pipe, so that will just fit over, and then we'll just run a weld around the inside just to secure it off, and probably a couple of tacks on the from the pipe side. Probably have to do that on the car just so that everything lines up with where it needs to be. So yeah, another successful fabrication project brought to you by the shed, beer, and a nice welder. So have a good weekend, good night, good morning, wherever you appear to be watching at, and we'll see you for the next one.